All right, if you're gearing up for your GCSE computer science exam, you've landed in the perfect spot. Today, we're cracking the code on secondary storage, that's spec point 1.2.2. You ever stop and think where all your photos, your games, your coursework, where it all actually goes when you power down your computer? Yep, that's what we're talking about. So let's get right into it. So here's the game plan. First, we'll cover why we even need this stuff. Then, we'll dive into the three main types you've got to know for the exam. After that, we'll put them head to head, see how they stack up, and then apply that knowledge to some real exam-style questions. And to finish off, we'll do a little quick-fire round just to make sure it all stuck. Sound good? Let's go. Okay, section 1, why we need storage. So first things first, why is this even a thing? Well, you can think of it as your computer's long-term memory. It's the part that, never forgets. And that really brings us to a huge question. I mean, you can be working on a project, shut your laptop, come back the next day, and it's all still there. How does that work? Well, the secret is that your computer is actually using two totally different kinds of memory. And this slide is the key to understanding it. On one hand, you have primary storage, like RAM. The big word here is volatile. It means when the power goes off, poof, everything inside it vanishes. It's super, super fast, which is perfect for running the apps you have open right now. But for everything else, your operating system, all your files, your photos, your game saves, you absolutely need secondary storage. It's non-volatile, which is just a fancy way of saying it holds onto your data even when the power's off. It's like the computer's digital filing cabinet that keeps everything safe and sound. So, section 2, the three storage types. Now that we know why we need it, let's meet the main players in the game. For your exam, you just need to get your head around these three contenders. And here they are: optical, magnetic, and solid state. I guarantee you've used all of these at some point, even if you didn't know their official names. Let's break them down one by one. First on the list, optical storage. This tech uses a laser beam to burn tiny little pits onto a spinning disk. That's how it stores the data. And then a laser reads those pits back. You know these well. We're talking CDs, DVDs, and Blu-rays. Next up, we've got magnetic storage. This is the classic, the real workhorse. If you were to open up a traditional hard disk drive, an HDD, you'd find these spinning platters that look a bit like tiny records. A little arm with a read-write head zips across them, magnetizing tiny sections to represent all your ones and zeros. Magnetic tapes, which are often used for huge backups, they work on pretty much the same principle. And finally, we have the modern champion, solid-state storage. Now, if you remember one thing about this, make it this: there are no moving parts. None. Instead of spinning disks and moving arms, it uses something called flash memory. It's basically like a giant lightning-fast USB stick. This is the tech you find in solid-state drives or SSDs, and of course in your USB sticks and SD cards. Okay, listen up, because this is a huge exam tip. The official spec says you do not need to know the super complex internal workings of these things. Phew. So don't stress about the physics of lasers or how magnetism works on a platter. What you do need to focus on is what makes them different and how they compare to each other. Section 3, comparing the tech. And that leads us perfectly into what is probably the most important part for your exam. It's time for the ultimate showdown. How do these three technologies actually stack up? Let's start with a big one: cost. How much bang do you get for your buck? Well, as you can see, magnetic storage is way, way cheaper per gigabyte. And that's exactly why those big traditional hard disk drives are still so popular for storing massive amounts of data. Solid state, on the other hand, is a lot pricier. It's why a lot of modern computers actually use a combination of the two: a smaller, super-fast SSD to run the operating system, and a huge, cheap HDD for all your files. Now let's talk about speed, and this is where the tables completely turn. Solid state is just ridiculously fast. Because there are no moving parts, your computer can grab the data electronically almost instantly. Magnetic drives are slower because they have a physical delay. The disk has to spin up to speed, and the little arm has to move to the right spot. And optical? Well, that's the slowest of the bunch, as you probably know if you've ever waited for a game to install from a disk. And here it is. This is the hero slide for your revision. Seriously, burn this table into your brain. Let's do a quick run through. For capacity, magnetic is the undisputed king. You can get massive HDDs. Optical is pretty low. For portability, solid state is the clear winner. Think of tiny USB sticks and SD cards. Durability is a massive win for solid state too. With no moving parts, you can knock it around a bit. Drop an HDD though, and you could be in big trouble. And optical discs, they scratch so easily.
That leads to reliability. Fewer moving parts means solid state is just less likely to break down. And finally, as we've already seen, solid state is the fastest, but good old magnetic has the lowest cost per gigabyte.
Section 4, choosing the right device. Okay, so you know the theory. Now let's put it into practice and apply it to the kind of scenarios you're going to see in your exam. All right, scenario number 1. Imagine a school needs to back up its entire network. What are the keywords here? I'm seeing cheap, high capacity, and portability isn't a major issue. So which device fits that description? The answer has to be magnetic tape. It just ticks all the boxes, doesn't it? It has an absolutely enormous capacity and the lowest cost per gigabyte you can get, which makes it perfect for those massive long-term backups where speed isn't the #1 priority. Okay, let's try another one. You're building a top-of-the-line gaming laptop. The keywords to focus on are load instantly and laptop, which means it needs to be tough enough to be carried around. So, what's the best choice? It's got to be a solid-state drive, an SSD. Why? Well, you need that crazy high speed for those instant loading times, and you need its high durability, thanks to having no moving parts, which makes it the perfect choice for a device that's going to be on the move. See how we're doing this? We're just linking the needs of the scenario right back to the characteristics in our table. That's the skill that gets you the marks. Section 5, Exam Quickfire. You're doing great. Let's pick up the pace and finish off with a quickfire round to really put your knowledge to the test. Ready? First up, a musician at a concert wants a cheap, portable way to sell their album. What do they use? And next, a film editor is moving massive 4K video files around. They need speed and they need it to be safe, which means it has to be durable. What's the right device for the job? And the answers are, for the musician, an optical disc, a good old CD, is still one of the cheapest ways to mass-produce physical copies of music. And for our film editor, a portable SSD is really the only sensible option. It's got the incredible speed needed for those huge files and the durability to be carried from one studio to another without any worry. And there you have it, secondary storage cracked. We've looked at why we need it, the 3 main types, and how to compare them to absolutely nail those exam questions. But let me leave you with a final thought. With cloud storage everywhere now, will these physical devices we hold in our hands even matter in the future? Just remember, the cloud isn't some magical thing up in the sky. It's just a network of huge data centers filled with thousands upon thousands of the very magnetic and solid-state drives we've just been talking about. The real question is, will we always need them right here with us? Thanks for joining me, and best of luck with your revision.